2, 1. Howdy, howdy, this is Mr. Potter. In the next series of videos, we're going to be talking about another type of data structure, the stack. So in this video, we're going to talk about what a stack is, what it represents, and as well as how to implement it using arrays. So I want to start by talking a little bit about what is a stack. So I think most of us are familiar with the idea of, I've got some table here and I put a sheet of paper on that table. So this sheet of paper is on the top of a stack of papers, and I can put a second sheet of paper, and notice that the second sheet of paper covers up that first sheet of paper. I really can't see what's on the blue sheet of paper without looking at this pink sheet of paper and taking this pink sheet of paper off. And if I put some third sheet of paper on top of that, well, now this third sheet of paper is really the only sheet of paper that's accessible. So the idea behind a stack is that we're going to be taking objects and putting them in a particular position. We'll be adding objects, but the idea is that once we add an object, the object below it won't be as accessible. So we can put objects onto a stack. And of course, the idea is once I put on object 3, then objects 2, 1, and 0 are going to be hard to see. So you can imagine I've kind of got an eye looking at it, and I can only see the top of the stack. But then I can also take things off of the stack. So I could take 3 off the stack, and now my eye can see 2. I can take 2 off the stack, and now my eye can see 1. So I can put things on a stack, I can take things off of a stack. I certainly could tell if a stack is empty. And of course I can peek onto what's on the top of a stack. So this is important. This is what we're going to be talking about. The 3 things that we need to be able to do is we're going to need to be able to push something onto the stack. So this adds to the stack. I'm going to need to take stuff off the stack, and the term that we use for this is a pop, and this is going to remove from the stack. In other words, this is destructive. Once I take it off the stack, it's no longer involved with the stack. And the third thing I should be able to do is I should be able to peek, and this would be the non-destructive. In other words, I should be able to see what's on top of the stack and deal with it. Now, the other thing is that because we are going to be implementing this with arrays, my arrays tend to have a fixed length. So I'm going to have position 0, 1, 2, 3, and I'm going to put stuff into my stack, and I'm going to take stuff off of my stack, which means I need to keep track of whatever the top of my stack is and whatever the bottom of my stack is. So I'm going to have to keep track of a top, I'm going to have to keep track of a bottom, and I'm going to need to have some way to resize my array, because whatever size my array is, it may not be big enough to hold all the data. So I'm going to need to be able to resize it, but I'm also going to need to know if I need to resize. So the idea is, let me redraw this because I drew this wrong. If I have some array, so let's say I've got box 0, box 1, box 2, box 3, box 4, box 5. I'm going to be able to put a number in the stack, like a 3. So that was the head of my stack. That tells me the first position that's available, and that really tells me where stuff is. But now I need to add stuff to the stack. So if I added a 7 to the stack, now my head is no longer pointing there, it's actually pointing here. And if I add another number, I can add a 2, I can add a 9, I can add a 6. All of these things are being added, and my head moves along. But then I pop, and if I pop, well, now this 6 is going to be gone, and my head is going to be back to here. And if I pop again, well, now the top of my stack is here. If I pop, my stack is here. And of course, anytime along the way, I could have peeked to see what was on the top of my stack. But eventually I'm going to reach a situation where once I pop the last thing off, there really isn't anything back here to go to. So in other words, I need to introduce the idea of an error. Now in Java, we would talk about the idea of an exception, being able to throw an exception, to create an exception. And what we did is we extended the exception class, or we implemented some interface in order to do this. And we're going to have to do something very similar here. So looking at this, how do we want to handle an empty stack? Well, one of the things we need to do in order to, do anything special with C++, one of the things we've noticed is that we need some type of include. And so we're going to have to include something. And what we're going to include is std except. And this is going to give us all of our exceptions. And inside std except, there is a standard exception which we're going to be using called out of range. So out of range is an exception. You can think of this as your index out of bounds exception if you were doing this in Java. You're basically saying that something is outside of the normal range of operation. Now, we have the ability to resize a stack if our stack isn't big enough. We can always make a larger array and copy the data over. We'll talk about how to do that in code in just a bit. But if I have an empty stack, I need to be able to deal with it. And what I can do is, this is actually a function where I can put some type of error message as the parameter. And so we're going to put some type of error message like, hey, the stack is empty. So we would just say, hey, empty stack. And of course, once we've thrown this exception, this kind of does flip the table. It kind of stops everything that we're doing. This shuts down our program. This is going to send an error message to anything that calls it. So you need to be aware that this is the end if this happens. So we kind of need to avoid that situation. Now, in later videos, we'll talk about the idea of trying and catching. If I wanted to be able to deal with an error and kind of safely handle it. But for right now, I just want to have the notion of, okay, how do I let the user know that something irrevocable has happened, something that has crashed the program? So that's what we're going to be talking about in today's video. Today we're just going to be implementing the class using an array. Later on, we're actually going to be applying this, so writing programs that would use this. So the first thing I'm going to do is I'm going to create a file. Excuse me. So I'm going to call this arraystack.h. And so this is going to be my .h file, my header file. So arraystack.h, and I'm going to define stack underscore h. Now, later on, we're going to implement the stack using different types of data structures. Right now, we're just doing it from an array standpoint. And so that's why I'm doing this define stack, because this is just a stack class that we're going to be creating. Remember that if I want to be able to create a stack of ints or a stack of chars or a stack of fractions, I need to have a template. So I'm going to do template class T, and we're going to be using this. So now I can create my class stack. Now, remember that whenever we're creating a class, we have private data, and we're going to have public data. So our private is going to be our instance variables. So keep in mind that a array stack needs to have an array, and an array really is a pointer. So I'm going to have a T pointer called data. I need to keep track of the top position of my stack. So I'm going to say int top. I need to keep track of the size. So int size. And we talked about how to find the size of an array before using size of. And really, the user should not be able to resize or determine if we need to resize. So our resize function is going to be of type void, and we're going to have that be a private function. And similarly, the idea of need to resize, that really should be a bool, a private function as well. So this is our private setup. We have the data that we're going to be storing, the array itself, and it's really a pointer. We have the top position in our stack. We have the size of our stack, whether or not we need to resize our stack in case it's not big enough, and if we need to resize it, then of course how we resize it. What the public needs to be able to do, the public needs to be able to create a stack. So we're going to have a constructor. Now our constructor is going to do some very simple stuff. It's going to initialize our data. So we're going to say size gets 5 just to start off. We're going to create a new array of size, whatever size happens to be. And we're going to set our top position to 0. What's nice about this is that it tells us where our first piece of data is, as well as how to access that place. All right. Outside of the constructor, we talked about what the user needs to know. So the user should be able to push, and keep in mind push is a mutator. So they're going to be pushing some item. They should be able to peek. Remember, peek is the non-destructive accessor, so they don't need to give us any information to peek. And then we have pop, which is a destructive accessor. This is actually going to change the state of our stack. And then I think we should have a simple function called isEmpty to see if the stack is empty. In other words, if we're going to be throwing exceptions, if our stack ends up being empty and we're manipulating an empty stack, then we really should give the user some way to determine if our stack is empty. So that's the end of our class declaration, and then we're going to move on. So we're going to include arraystack.cpp. So this is our header file. I'm going to go ahead and save this, and then we're going to move on to our actual functions that we've created. So we're going to call this arraystack.cpp, and we're going to check to see if arraystack.h has been loaded. So this is using the if not defined. So in other words, if the idea of stack underscore h has not been defined, then we haven't loaded, we're not including the .h file, we're including the .cpp file. And we need to make sure that we include arraystack.h. And then that's the end of our if statement. So now, I need to write those methods, but I also need to make sure I include std except. And then remember, that allows us to throw the exception if we try and manipulate an empty stack, so we don't have an index out of bounds or a null pointer exception. All right, so the first thing I need is the idea of pushing. So remember, these are all going to have the template class T above them. So I'm going to do void, and this is going to be from my class stack templated with T. This is our push. And remember that push is going to be receiving an item. So the idea behind receiving an item is the first thing I need to do is see, hey, do we need to resize? Remember, this is a function that gives a Boolean variable. If we need to resize, then we're going to resize. And then we're ready to put data in. So we can say data sub top is going to get whatever item is, and then top is going to be incremented. So this is our simple, if I need to resize it, then I go ahead and resize it. And then I need to put the data that they give me into our array. And then I need to say, hey, that's not the top anymore. That's not where stuff is going to go. You need to go somewhere else. Now, this does bring up an interesting point. I'm going to do something real quick. I'm going to write over here. The idea is that if I have an array, top is going to be pointing at position 0, which is the first spot that stuff can go into. So if this is the first spot that stuff can go into, as soon as I put a piece of data in here, top is now pointing here at 1. Keep in mind that top is pointing at 1. This is where insertions can happen. But this is not where my last piece of data is. My last piece of data is actually 1 over. So I need to make sure that I put my data in the correct spot. So let's go ahead and get rid of this. What that means is that in my peak and in my pop, I need to make sure that I'm referring to the spot before. So let's go ahead and do this. So I'm going to have template class T, and I'm going to do, remember that my pop or my peak is going to return an item of type T. So stack template T, peak. We'll do the non-destructive first. The other one's going to be really easy to take care of because we'll just return it and actually change the top of our stack. So if top is equal to 0, or actually if top is less than or equal to 0, just in case something happens, then this is where we want to throw our error. So we're going to throw a std : out of range. This is where we're throwing an out of range exception, and we're going to say empty, or we could actually say a little bit more here. We could say attempted to peak an empty stack. So a nice error message that describes exactly what happened. So anyone who's implementing our array stack knows exactly why they're receiving an error message. Now, keep in mind that this stops the program. So if I make it to this next line, then there's clearly some piece of data that I can get. So what I can do is I can return whatever's in my array, but keep in mind I want to return what's in top -1. So I want to return what's in the previous spot. So that's my peak. So now I want to take a look at how pop is going to look like. Remember, pop actually changes my stack, which means pop changes top. So template class T, and we're going to be returning an item of type T, stack template T, pop. And I'm going to do the same idea as before. If top is less than or equal to 0, then we want to throw a out of range error. And this time I'm not trying to peak, I'm attempted to pop an empty stack. But again, if I reach this point in my program, then there's nothing wrong with the stack. My top is okay. So what I'm going to do is I'm going to top minus minus. Now keep in mind, this serves two purposes. One is that it lets me access the previous position in the array, and two, it sets top to its new value. It's pointing to the next position that I can add data to, and then I can peak or pop later because my top has changed. So now all I need to do is make sure that I return data sub top. Okay, and I don't have to do the top -1 like I did when I peaked because this is destructive. I've actually changed top to the top value that it should have afterwards. So we're okay with that. All right. So I've taken care of push, I've taken care of peak, I've taken care of pop. Now I need to take care of the data itself. In other words, whether or not I need to resize, and if I need to, how I would actually go about resizing. So again, template class T, and this is going to return a Boolean variable. This is our Boolean function stack template T need to resize. And the idea is that if top is equal to size, remember our variable size is keeping track of how large our array is. If top is pointing at size, that means we're not going to have a place to add data to. So what I really want to do is I really want to return the result of this evaluation. If top is equal to size, then yeah, I need to resize. I don't have any more spaces to put data in. Because if I have a size of 5, that means my largest index is 4, and I'm going to be putting data in position 5. So if top is equal to size, I need to resize, I'm returning true. If top isn't equal to size, that means that I still have spaces to go and I don't have to resize, I'll return false. So then how do I actually resize? Well, if I want to resize, let's do this, template class T, and then this is our void stack template T : resize. So if I'm going to resize, I'm going to do several things. The first thing I'm going to do is I'm going to set up a new array called new data. And this is going to be a new array of size, let's say 2 times whatever size is. The idea is that if I don't have enough data, if I don't have enough space in my array, well, let's double the size of the array. So 5 becomes 10, and if 10 isn't enough, then 10 becomes 20. The idea is that once I do this resizing, I hopefully won't have to do it too many more times afterwards. The idea is that I'm really kind of compensating that if I don't have enough space now, I'm making sure I have enough space for my goals. And then I need to take all the data that is currently in our old data array and putting it in this new data array. So for int I gets 0, I is less than size, I plus plus, and what I'm going to do is copy the data over. So new data sub I is going to get data sub I. So that copies all of our data over into this new array called new data, but I need to make sure that I keep track of that new data array. So data gets new data. That means that my pointer is not going to be pointing to my old array. My pointer is going to be now pointing to my new array. And then I just need to keep track of the size. The size is going to be multiplied by 2. All right, so we're going to save this, and we're going to compile this. So G++. I'm just going to compile it just to see if it does compile. I'm going to get an error because I don't have a main method. But let's go ahead and compile arraystack.h. Okay. Notice that it compiles with no errors, no issues, because I've told it exactly what I want to do. I've taken care of my private variables, my constructor, and my accessors and mutators. And then over here, I've written the code for it. All right, so let's try and use this. Let's create a new file. We'll call this arraystackTester. So we're going to make sure that we include IOStream. And we're also going to include our new file that we just created, arraystack.h. Okay. So the idea here is that I want to create a new stack. So I'm going to say stack of type int, and I'm going to call this S. So S is going to be the name of my stack. And then what I'm going to do is I'm just going to fill this stack up. So let's do cout s.isEmpty. Did I write isEmpty? Let me see if I wrote isEmpty. I should have written isEmpty. I didn't write isEmpty. Let's take care of that real quick. So template class T, and then this is going to be a bool, stack T : is empty. And remember, the idea behind is empty is just if my top is equal to 0, then I'm empty. So all I'm going to do is just return the result of that evaluation. And I do need to make sure I make that top equals equals. I do not want to make that mistake. So I'm going to return whether or not we're empty. Let's go ahead and save that arraystack.cpp. Save all of our files so far. So I'm going to test this is empty. And then what I want to do is I'm going to set up a loop, and I'm going to add stuff to my stack. So I'm going to say s.push, and I'm going to push I times I plus 1. So I'm going to push 0 times 1, I'm going to push 1 times 2, 2 times 3, 3 times 4, and 4 times 5 onto my stack. So when I'm done with this, I should have 5 elements in my stack, and my last element should be 4 times 5. So I should be able to see out s.peak, and I should get 4 times 5. I should get a 20 out of that. And then what I want to do is I want to take the elements off of my stack. So I'm going to say while s.is empty, and I don't want it to be empty, so while it's not empty, if it's not empty, I should be able to remove things from it. So while it's not empty, I'm going to see out s.pop and a space, and then make sure that I take care of my fence post problem. And then return 0. So we're going to try that. Let's see how this works. So I've saved it. Now we're going to compile arraystackTester with an output file of arraystackTester.exe. Okay, we've got a few issues here. Let's go ahead and make sure we got this taken care of. Oh, I forgot my using namespace standard. Ooh, I need to fix that. So using namespace std. Let's try that again. Much better. So at this point, I've got my arraystack.h, I've got my arraystack.cpp, and I've got my arraystackTester, and I know what the results should be. I know if the very first time if I ask if it's empty, it should be empty because I haven't put anything in here. So I should be getting a 1 out of that. Then I'm going to push these elements on. What I'm doing here is I'm pushing 0 times 1, 1 times 2, 2 times 3, 3 times 4, and 4 times 5. And then when I peak, I should be able to get that 20 off of it. And then when I go through this loop, I'm actually going to be popping, so I'm going to be removing stuff from this. So the first thing I'll remove is the 20, then I'll remove the 12, then I'll remove the 6, then I'll remove the 2, then I'll remove the 0, and then it'll be empty, which will break out of the loop. And then I'm going to end the line. So let's see how this works. So we're going to run an arraystackTester. Okay, and we got our expected results. Notice the first thing that happens is our result is 1 because it is empty. Then I peaked, and the top of my stack is a 20. And then when we did the popping in order, because it is a stack and it's going from the top to the bottom, it takes the last thing we entered first. What's important to notice is that whenever I'm dealing with a stack, we actually call this an FILO, or first in, last out. So this is a FILO data structure, first in, last out. In other words, in my stack, I started off by putting a 0 in the stack, then I put a 2 in the stack, then I put a 6 in the stack, then I put a 12 in the stack, then I put a 20 in the stack. I peaked, and I saw the 20, and then when I popped, the 20 was gone, the 12 was gone, the 6 was gone, the 2 was gone, and the 0 was gone, printed in order down here. So we've got our stack implemented. So in our next couple of videos, we're actually going to be implementing this stack. So once again, this is Mr. Potter. Thank you for watching. Have a great day.